Hi and welcome back. Sorry, I guess I kind of ran out of time at the end of that video, and I think I might have been sort of rushing towards the end of that video. So let me just say, we were going over jump discontinuities, and we were taking a look at, I was saying that most of the functions that you're going to see when you take a look at jump discontinuities, they're really almost always going to be in this form, or at least all of the ones that fit the typical definition of a jump discontinuity are going to be these piecewise definitions of functions where you have some value, where you have some function of x squared and some region that your function is going to be that value, and then some other function and a different region for that. And that's going to be your typical jump discontinuity. But you can also have this type of jump discontinuity where you're taking the absolute value, where pretty much absolute value is somehow involved in your function. And typically it's of this form, where you've got the absolute value of something divided by that same something. So anyway, let's keep going with this. And in the last video, we were showing that if we had a table of values here, we could show that for any value of x that we chose that was less than 1 here, think about what we're going to get. For any value that's less than 1 here, we are basically going to be dividing something by that same exact something on the top. But keep in mind that for values less than 1, we are going to be dividing something positive on the top by something negative on the bottom. That's always going to be the form for x's, and let me actually throw in the limits there. So for on minus infinity up to 1, that's what our form is going to be. We're going to have something positive in our numerator divided by something negative in our denominator. And this is always going to be, so it's always going to be 1 times negative 1, pretty much. We're always going to have a line at negative 1 on this interval from negative infinity up to but not including 1. Similarly, if we were going to do the same configuration, if we were going to try to fill out some more values to figure out what this thing was defined at past x is equal to 1, or in the positive direction of x is equal to 1, let's actually go ahead and choose, let's say x is equal to 2. Actually, let me choose a different color. There. X is equal to 2. So we put into the top of our function 2 minus 1, that's equal to 1. Take the absolute value, that's still equal to 1. Divide by 2 minus 1, that's also 1. And that's just equal to 1. So at the point x is equal to 2, f of x is going to be equal to 1 up there. Similarly, if we did the value at x is equal to 3, 3 minus 1 is 2, absolute value of that is 2. Divide by 3 minus 1, that's also 2. So that's equal to 1. So then we've still got that point right there. And hopefully you can see again that for all the values, and let me write down this interval, from all the values from 1, not including 1, so the open interval from 1 to infinity, we're going to have the form of something positive on the top divided by something positive on the bottom. So then we're just going to have this line at y is equal to 1. And then right here at the value of x is equal to 1, we're going to have our undefined open circle here also. So hopefully you can see that this is going to be the graph of this particular function. And this isn't a piecewise definition of a function. It's a function just using absolute value. And we can very clearly see that this function is going to be a jump discontinuity. And we can even do this. We've got some time in this video, so let me just go ahead and see if it fits with our definition of discontinuity. Just say the limit as x approaches 1 from the negative side of g of x as we approach in this direction. So we're getting really close to 1 from the negative side, and we're looking at our function, and we can see that that is going to be equal to -1. Similarly, if we were going to approach from the other side, the limit as x approaches 1 from the positive side of g of x, that means we're taking numbers that are really close to 1, but just a little bit bigger than 1, and we're looking at what the behavior of our function is. We can see that the value that our function is going to approach there is going to be 1. And then we can see here that these two values, -1 is not equal to 1, so therefore the limit as x approaches 1 from either direction, so we're not going to put a direction in there, of our function g of x does not exist, and therefore we have a discontinuity here. So anyway, hopefully you found that useful, and I guess that's pretty much it for our different types of discontinuity. So hopefully that gives you a little bit of insight on the different types of discontinuities that you're going to see, and I'm just going to highlight them again. We've got our infinite discontinuity, our removable discontinuity, and our jump discontinuity. So anyway, hopefully you found that useful. And finally, now in the next video, we're actually going to start doing some examples. So I'll see you soon. Thanks for watching.